Hello, everybody, and welcome back to this software archaeology series. Today, we are trying to run for the 2BSD from 1983. And let me provide, before jumping into the command line, some background on why are we trying to achieve this. I had curiosity. I wanted to actually know how the old TCP IP stack from 40 years ago can still work nowadays. It's possible that a software stack that was written 40 years ago could actually run nowadays. Well, that's part of the question I wanted to answer, because this year, 2023, it's been 40 years that internet started to be deployed as we know it. And this is something I won't go into details, but before that date, uh, the internet predecessor was the Arpanet that had been deployed, or had started, in the early 1970s between some of the universities and research centers that the ARPA agency uh, sponsored, or used to sponsor. Many of the main universities of the United States started that network that was the internet predecessor. But that network was significantly different uh, from internet. To researchers, nowadays more than famous, Robert Kent and Vint Cerf, uh, w- working back in those days for RPA, they had envisioned the new protocol that superseded the original ARPANET protocol that was called NCP. TCP/IP was the next generation and was intended to build a network of networks. They originally called that concept internet working, and it's basically the beginning of internet as we know it. The following question is how this version of BSD can run in 2023. The answer is this piece of software cannot run in a PC architecture. It was built for a big mini computer like this one, a VAX 7080 from Digital Equipment, that it was as big as a set of refrigerators uh, put together in a data center. Of course, there are a few of those computers, and it wouldn't fit here in my apartment. So the part of this emulation, it's done with a piece of software that a guy that used to work for DEC, that it's called Bob Sapnik, developed some years ago, and now it's being maintained and enhanced by a community of developers. The software is called SimH, and it's able to emulate a whole bunch of computer architectures from the past, from Altair 8080s to the classic PDPs where Unix was started. So today we are running a VAX 7080 with version 4.2 of BSD. And how this can be installed and run? Well, actually following this recipe from this site, I'll put it in the video description, and it is basically a recipe for installing 4.2 BSD. If we go back to the original BSD manual that was written by Bill Joy in 1983, it basically described pretty much the same steps we are currently doing in order to run the system on CMake. That's pretty similar. The only difference is here in our configuration file we are dealing with virtual disk, with virtual virtual network interfaces, and so on and so forth. Basically, everything is emulated by software. So, without further ado, let's jump into the command line. Let's turn on DevX and let's run 4.2 BSD. It took a while. The installation, it's kind of difficult, and the only thing I needed to do was to include the support in the kernel for an Ethernet device. Back in the day, an Ethernet card supported 3 megabits, 3 Mbps, compare it with a gigabit Ethernet we have nowadays. So if we log in, we will be welcomed with this message of the day, and that really caught my eye because I remember an old film from the 80s that was war games. We can see it here, this film in which the main character Matthew Broderick used to word dialing and log into a computer from some defense, a computer from the defense area, and started a dangerous game. And that's kind of something funny I found here in 4.2 BSD, because this release was from 1983 as that film. And one funny thing is that a user, it's called Falcon, from processor Falcon, from that film. That's the professor that was responsible for the artificial intelligence program that the big computer on that film ran. If by chance we can log in with his credentials, we use the same password that was used in the film, this Joshua, and we are welcome with that message. Funny, the only way to win is not to play at all. That's something I found really funny. Well, maybe it was much more fun for hackers from 1983. But let's go back to 4.2 BSD. One thing you'll find is that the file system hierarchy, it's kind of different to related to modern Linux or Unix derivatives, but it's kind of for the people that it's interested on BSD. This original BSD, it provides a lot of details and explains very well many design decisions from BSD. They are a set of daemons that are running: telnet daemon, root daemon for RIP protocol, FTP, syslog, send mail, the mail server, and the, well, this is something I added. It's the network configuration script. You can find it there, and we've got Ethernet already set up. Something I forgot to say is that in order to CMH to actually run, we need a tap device. You can see here, this is my Linux machine where CMH is running. We've got the tap device, that it's the virtual device that BSD will use, that it's in turn bridge or connected to a network bridge and to the physical network. That way CMH can get communicated with the rest of the world. My local network and some far away servers as well, we'll see. One important thing is that in 1983 still there wasn't DNS, there wasn't name resolution, so they had to deal with a big etc host file that described a list of the host names that used to comprise the internet as it was in 1983. Around 600 hosts span throughout the United States. And well, we've got a bunch of applications that are considered unsecure for nowadays standards. Let's see, there's also something that got my attention, was that there wasn't a ping tool. There's no ping tool at all, and that is because the guy who actually wrote the ping utility, he did it around 6 or 7 months after 4.2 BSD was released. The next release, 4.3, it included the ping command. So following Berkeley convention name, I set up a couple of hosts in my internal network, my local network. They used to use painter names as host names, so I set up a couple of them. Now I am on this host Soldi, and I'm going to connect to the other one that it's in my local network as well, that it's called Kinkela. Let's try to run an FTP, and we will use the user from a historical developer of BSD, that it's Marshall McCusick. And voila, we are connected by FTP. We can do the same. We can log in remotely using Telnet. And you see, we are on the other host. Of course, these protocols are considered absolutely unsecure today, as those two protocols were the first set of applications developed by ARPA in the early days of Arpanet. But there are others that were included on BSD. They were developed at Berkeley, such as remote login. Let's try to log in remotely into Kinkela, and you see The remote host absolutely trusts its counterpart because it has a file here, host.equiv, that it lists the host names of machines the system can trust. As simple as that, and it becomes as dangerous as that. Other utilities were, for instance, remote shell. If we take a look at the man page, remote shell, we can, for instance, run remote shell, the host name and the command uptime, and we'll get the response. Other utility are some of the predecessor of SSH or SCP. For instance, let's write a simple file. Let's first set the term we've got this file here locally, and let's try to not SCP, RCP test.txt to kinkela /tmp. Let's see, we can run a remote shell. Voila, we've got that file on the remote system, and that's the content of that file. Probably the most difficult thing to set up here was the mail server. If we go to user level, you'll see that the whole file system hierarchy, it's absolutely different from a modern Unix system. Let's see some of the initial lines of the configuration file. Send mail, it has a fame of being a difficult mail server, and in fact it is, but it is an incredible piece of software that it's still alive after 40 years as well. I would probably choose to use postfix, but you can go and use send mail on a current version, of course. The difficult thing in this old version of send mail is that there wasn't still a standard for the mail applications. Of course, SMTP was the ARPA protocol, but there were UUCP, Berg Mail, and some other mail solution from different networks, and send mail was able to deal with pretty much all of them. So this was the difficult part. Let's try. I'm gonna log in with my user. I have some emails on my inbox, but let's try to send an email to a person on the remote host. I am sending you an email from Soldi, and I'm gonna send it to Marshall McCusick at kinkiala.arpal. Hi, Mr. McCusick. Hope you receive this email. And voila, send mail is telling us that apparently it has delivered the email to the remote system. So let's try. We should have seen some traffic here on TCP dump going back and forth from the two instances of SIMH. The other instance, it's on a different computer here in my LAN. So let's try to log in from the Linux machine, my host machine. Let's see, this is a Debian machine, and let's try to log in by using telnet into Kinkela, and let's log in with Marshall's credentials. It's saying that he has an email, and we can see it here. Hey buddy, I am sending you an email. And here's the body, the email body. I found this pretty amazing. Yeah, I think if we had some DNS, or we can eventually set up some email, some smart host, and we could maybe send email to the real internet from BSD 4.2. Probably that's something we can try later on. And one last thing I'd like to do is try to log in by FTP. Let me get the IP address of the FTP server from the new project. Of course, there aren't many FTP servers out there nowadays. See, we are anonymous, and voila, we have connected from 4.2 BSD to GNU.org FTP server. As you can see, we are getting the control, the messages that come through the control channel from the FTP protocol, but it says here that we should consider using the passive mode, and that's something that this FTP client lacks of. It had no passive mode at all. So if we try to list the directory, we cannot get the data because we are behind a NAT router, and that's the reason why FTP doesn't work completely, but we were able to connect to a modern server. I find that absolutely mind-blowing. A TCP protocol stack that was developed 40 years ago is still working. That's something really amazing. And in fact, I don't know, this video, it's kind of or a way to honor those people that actually built this stuff, and many decades after, that stuff still works. That's all for the time being. See you. Hope you enjoyed this as I did, and see you around. Take care.